Hello all, welcome to a new video on logic design. This is the last video of the segment KMap. This video is about the simplification of SOP and POS expression using a 4-variable KMap. We have already learnt about the simplification of SOP and POS expression using the 2-variable KMap and 3-variable KMap in my previous lectures. Check out the playlist titled KMap for all these videos. If you are new to my channel, check out the videos on the selected topics from the course of Logic Design and the solutions of the previous year question papers of Logic Design. The links of all those videos have been given in the description box. So without further delay, let's get started. Let us start with this example. Reduce using mapping the expression f is equal to summation m 2, 3, 6, 7, 8, 10, 11, 13, 14. So first of all, we have to draw the KMap. A 4-variable KMap which consists of 16 cells and the variables are A, B, C, D. And now you have to place ones in the corresponding minterms given in the expression. So the corresponding minterms are 2, 3, 6, 7, 8, 10, 11, 13, 14. Here one cell represents one minterm. Therefore, this particular cell represents the minterm M2. Therefore, place 1 in the cell number M2. Similarly in 3, 6, 7, 8, 10, 11, 13 and 14. So the mapping is done. Now the next step is grouping. That is, we have to group the ones which are adjacent. Here this M13 does not contain, it doesn't have any adjacency. That is, the adjacent cell 15 is vacant, 9 is vacant, 12 is vacant, 5 is vacant. So this M13 does not have any adjacency. So we can consider this as it is. Now cell number 8, 9, 11, 10 are considered as adjacent with 0, 1, 2, 3. These cells are adjacent to each other. Similarly, 0, 4, 12, 8 are adjacent with 2, 6, 14, 10. These cells are adjacent to each other. Therefore, we can group these two cells M8 and M10. Similarly, we can group M11, M10, M3 and M2. And these four cells contains ones. And these four cells are adjacent to each other, so we can form here a group of 4. Similarly, we can form here a group of 4, that is 2, 6, 14, 10. These cells are adjacent to each other. Therefore, this forms a group of 4. Now, mapping is done, grouping is done. The next step is we have to read the map. So this group, the first group, this is called as A, B, C bar, D. This belongs to third row. Third row is called by A, B, and the second column by C bar, D. Therefore, this particular group is called as A, B, C bar, D. This group is called as A bar, C. Here, this particular group belongs to A bar, B bar, A bar, B, these two rows, and here A bar is common, therefore write A bar here, and this belongs to these two columns, that is CD and CD bar. Here the first term C is common, write that, therefore this group is called as A bar C. Now this group, a group of 4, this is called as CD bar. Here you can see this is called as CD bar. This is recognized with the term CD bar. And the last group, this one, these 4 cells, that is 11, 10, 3, 2, these cells, this group is called as B bar C. That is, here you can see A B bar and A bar B bar. Here B bar is common, that is written here, and in this CD and CD bar, C is common, that is written here. Therefore, this group is called as B bar C. Now we have one more group here, that is a group of M8 and M10. It is called as A, B bar, D bar. This is called as A, B bar, and this group is called as C bar, D bar, and C, D bar means we can consider D bar because D bar is common in both. Therefore, we can write this as A, B bar, D bar. So this group is called as A, B bar, D bar. So the reduced expression is A, B, C bar, D plus A, B bar, D bar plus A bar, C plus B, C plus C, D bar. So this is the reduced expression. Let us consider another example here. Reduce using mapping the expression f is equal to summation m 0, 1, 2, 3, 5, 7, 8, 9, 10, 12, 13. So here also you have to follow the same steps. The first step is draw the KMap, 4 variable KMap. A, B, C, D are the variables here. Now you have to place ones in the corresponding minterms present in the expression. So which are the minterms present in the expression? 0, 1, 2, 3, 5, 7, 8, 9, 10, 12, 13. So you have to mark ones. You have to place ones in the corresponding cells. And the next step is we have to group the adjacent cells which contains ones. So here these 4 ones form a group of 4 ones, that is 0, 2, 10 and 8. These 4 ones are adjacent to each other, therefore it forms a group of 4 ones. Similarly 12, 13, 8, 9, this forms a group of 4 ones. Now the next step is we have to read the map. So here this group is called as B bar, D bar. Second group is called as A bar, D. Third group is called as AC bar. So here whichever minterms are present in the expression, we have placed ones for those minterms and we have grouped them and we have formed a reduced expression for this. Now which all minterms are absent here? 0, 1, 2, 3, 4 is not there. 4 is absent. 6 is absent. 4, 6. Then 8, 9, 10, 11 is absent here. 14 is absent and 15. So those can be considered as max terms. Whichever minterms are not present here, those are the max terms of this expression. Now we will place zeros in the KMap for those max terms. So this given expression in POS form is f is equal to pi m 4, 6, 11, 14, 15. Now you have to follow the same step here. You have to draw the KMap, and the only difference is instead of ones we will place zeros in the corresponding cells, that is the corresponding max terms. So which are the corresponding max terms? 4, 6, 11, 14, 15. 4, 6, 11, 14 and 15. Now you have to group these zeros. So you will get 3 groups here, and the reduced expression is A plus B bar plus D into A bar plus C bar plus D bar into A bar plus B bar plus C bar. So how many inputs have to be given? 1, 2, 3, 4, 5, 6, 7, 8, 9, plus we have to give all these 3 terms to a AND gate. That is, again 3 is added to that 9, so that 12 inputs. Here you have to use 12 inputs, and in the previous case, that is in SOP form, we have to use only 9 inputs. Therefore, using SOP is economical here compared to POS. For POS we are using 12 inputs. Therefore, we can go for SOP for implementation. So let us implement the SOP expression here. For that we need the first NAND gate, The input to the first NAND gate is B bar D bar. The input to the second NAND gate is A C bar, and the input to the third NAND gate is A bar D, and the output of these NAND gates is given to another NAND gate in order to get the final reduced expression, that is B bar D bar plus A bar D plus AC bar. So this is the reduced SOP expression.